All right, guys, this problem says a square is cut on the diagonal to form two right triangles. The hypotenuse of the resulting triangles is 10 inches long. What is the length of each of the sides of the square? Well, to start, I'm going to go ahead just and draw the picture that this problem is describing. So I'm going to go ahead and draw a square to the best of my ability and cut it with a diagonal. So here's my square, or rectangle kind of. And I'm going to go ahead and cut this with a diagonal to create the two right triangles pictured. Let me switch back to my normal writing tool. All right, so now that this has been created, now that the diagonal has cut the square, I have two right triangles. So here's my right angles, and here's that hypotenuse. It's always across from your right angles, and it has a length of 10. I want to find the length of the sides of the square. Well, the convenient thing about squares is I know all the sides are equal to each other. So I can label my unknown sides x, and both of these end up being x, so with these up here, but I'm just going to focus on one triangle, one set. Well, I know that I can use the Pythagorean theorem to find missing side lengths when I have at least usually two side lengths of my right triangle. But the convenient thing here is since it's an isosceles triangle and I know these two are equal to each other, I should still be able to use the Pythagorean theorem. So I'm going to write down a squared plus b squared equals c squared. And I'm going to go ahead and say that my two legs here, x is a, and this other x is b, and my hypotenuse 10 is c. So I go ahead and plug in these numbers. I get x squared plus another x squared equals 10 squared. Now I can add these like terms together. So an x squared plus another x squared is 2x squared equals 100, because 10 times 10, 10 squared is 100. Now I can go ahead and solve for x using my inverse operations. Right now I'm multiplying x squared by 2, so I'm going to divide by 2 on both sides. I get x squared is equal to 50. Now I want to undo the square, or do the inverse of squaring, which is taking the square root. So I'm going to take the square root of both sides to get just x equals the square root of 50. So at this point, you have a couple of options. You can either use your calculator if the test question is looking for a decimal answer. So I'm going to go ahead and drag my Desmos calculator over here so you can see it. And in that Desmos calculator, I'm going to hit the square root symbol and type 50 inside. And I end up getting, so you can see it a little better, 7.07 as my decimal answer if I'm rounding to the nearest hundredth, which is 2 decimal places. So I'm going to write that down. So x is equal to 7.07. And we can think back for reasonableness. If x is about 7, I know that x squared, or 7 times 7, is 49, which is just about 50. And this is a little bit bigger than 7, so it should be a little bit bigger than 49 when I square it. The other option, or if depending on the multiple choice options for your answer, is you might have to put your answer in a simplified square root. So if I have 50, I can go ahead and find the prime factorization of that number. I know 50 is 5 times 10. Well, 5's prime, so I stop there. Then 10 is 5 times 2. So now I know 5 times 5 times 2 will bring me back to 50. These are all my prime factors. 5 times 2 is 10, times 5 brings me back to 50. Now, when we're taking the square root of something, we're looking for what times itself got me that number. Well, since I have 5 twice in my prime factorization, that means I get to pull it out of the square root, because 5 times 5 is like 25. And if I take the square root of 25, I get 5. So I pull the 5 out of my square root, but I have to leave the 2 inside because there weren't 2 sets of 2 that I was multiplying together. There was only 1. So the other option instead of 7.07 is 5 square roots of 2. Both of these are correct. If you enter both in your calculator by doing the square root of 50, all of them will equal the same decimal value as well.